Say hello to the new addition to my workshop, my new 3D printer. I got it about a week ago and I've been playing with it a lot. And I got to tell you, this thing is absolutely amazing. This thing is fast, really, really fast. Now I got the combo version. It's the printer itself and it's got that thing over there. Now that thing over there takes 4 reels of filament, and you can see that they're different colors. What it means is that I can actually do multicolor printing. Few tricks involved, but it does work. And the reason I really wanted this version, or this particular printer, is that everything that I read and saw about it told me that this thing was incredibly fast. Did I mention it's fast? It is incredibly fast. When I first put this thing on, this thing was flying around so much, I thought the prints were going to be a total piece of rubbish. And instead, they came out better than my previous printer. And my previous printer, believe me, I was getting old just watching it. It did its job, but it was incredibly, incredibly slow. I remember working with dot matrix printers in the old days, and when the inkjet came out, you notice that incredible difference in speed. Well, this is the same thing that I've experienced with this edition, and I've been playing with it quite a bit. And the reason I'm doing this video is I want to show you how I use it to design and build new undershelf modules, which were becoming a bit of a problem because I was running out of the actual enclosures. And I also wanted to make this whole thing completely autonomous, so I wouldn't have to depend on anybody, any other service outside of my workshop to be able to do them. This thing allowed me to do it. This thing has replaced so many stages of the work that I had to do to build those undershelf modules. And I'm going to show you one of them. This is incredible. Now, first of all, let me tell you, this printer was a gift from Bambu Labs. I did not pay for it. I wrote to them, told them what I did, gave them a link to my channel, and asked them if they would sponsor me one of these, and they decided to do so. The condition is that I will say exactly what I think. I have not been told or asked to say anything specific, and that's exactly what I do with anything that I accept on this channel. Now, you can probably guess I'm not going to give this usual sort of unboxing video that people do. I don't particularly like that. What I did do is follow the instructions. They were very, very easy to follow. There's also a video that I'll link in the description below, which is very, very well done and describes it in really great detail. Incredibly easy to put together. I got this thing working and printing within probably less than an hour, and most of that was watching the video. So it's really the sort of thing that you just get and you can use it pretty much straight away. So let me show you what I'm talking about when I talk about those undershelf projects. I've been building these undershelf modules with all sorts of little tools and pieces of equipment that I need. This particular one is the mini whip antenna selector. It's looking worse for wear. It supplies the mini whip with the DC voltage that it needs. It brings in the signal. It then allows it to come out here. And I had a FM antenna coming in straight through there as well. I wanted to make this selectable, and that part of it is coming in a future video. But what I wanted to do is build this whole setup, this whole enclosure setup in a more efficient manner. Now, I've been using these aluminum sections, which I had some metalwork shop cut for me. All this is, it's a rectangular section, and they cut there and they cut that off there, and it allows me to work on them. This is a 20 centimeter one. I also had 10 centimeter ones. I was limited to the 2 sizes that I had. If I wanted to use this, I'd need to get one of these cut somewhere, and I built up a bit of a stock, but I'm running out of them. Then I would have to design the faceplate, drill the holes, right? Drill the holes, and after putting the board in or whatever electronics I wanted to put in there, I can then very easily solder to them. This one is a real mess. That's why I wanted to change it. And then I would need to draw the faceplate as well. So I would draw that in a drawing program. I'd go to a printer's. They'd print it out on adhesive, self-adhesive paper or film, and then I would stick it on there. Sometimes I sprayed it with lacquer just to protect it, cut the film out, put everything through. If I scratched this at all, I had to redo the whole thing. At the back, I normally wouldn't even put a label on there, but I'd have to put one of these angle brackets on here so that I can connect it to the top. Now what I've done is I've made this whole thing 3D printable, and it really, really works out well. This is what I've got so far. Now, what have I got here? I've got the same profile because that's perfectly acceptable for me, and the shelf is already set up with these things. I 3D printed the actual profile. The advantage here is I can make it whatever length I want. I can make it bigger or smaller. I don't have to stick to the 10 centimeters or 20 centimeters. So that's the first advantage. Secondly, when I print this, I already printed with the holes in there. So I don't have to worry about drilling the holes, making them bigger or smaller, deburring them. The holes are there already, but there's something else here as well. I've made this as part of the enclosure itself, so I don't have to put that angle bracket on here. This particular one I've got to redo because I forgot to put the holes at the back. And the other thing is I can, because of this printer's color printing capabilities, I've also been able to do something else. And that is really one of the great advantages of having a color printer. And that is that you can actually print the labels. What I've done is I've made a label section which will be exactly the same as the front. So it fits perfectly, and I can print the labels on here. It's actually pretty good. This is raised, it's embossed. And the reason I did it on here is because when I describe to you how the 3D printing works, you'll understand why I wanted to do this separately. Actually, I'll explain it now. When I print this particular one, I print it vertically. And the reason is it works well for me. It then needs very few supports. The only supports it needs are under here. And it actually does build supports up to make sure that these holes are perfectly round. You wouldn't need them really, but I'll let the whole thing do its business. So I print this thing vertically. And then when I print this, I print it horizontally. And the reason is that when a 3D printer changes color, it actually changes the filament that's in the spool, in the head. So what happens here is you've got to think of this as a procedure coming from bottom to the top. It's starting at the bottom, right? It's printing from the bottom. First layer, second layer, third layer. So once I've printed this base in white, I now need to change the filament color to black. And if you see this Electronics Old and New logo, the beginning part is black. It's the same thickness as those letters. It's in black. So what it does then is the printer goes and changes the filament, and it cleans out the old filament, and little pieces get thrown around. The poops, as they call them. So it's wasted filament, a little bit of wasted filament. So it cleans the head of the white filament. It then fits in or spools in the black filament, prints the layers that have this text on it in black, including the base of that E, O, and New. And then it goes and changes filament again to red. So it cleans out the head again, brings in the new filament to red, and it prints the layers that are in red over here. Now this is actually done in medium quality. I haven't even gone to extreme. This one was printed in the fast version, so the lowest resolution. I think it was 0.2 millimeter layer height, nothing special. There's a preset for the various presets on the printer itself, and I used the one that would give me the quickest print. And then this one, I put it to a better resolution because I wanted a finer work on the lettering. And I am incredibly pleased with this. I am really pleased with this. Now, you'll be saying, well, this is plastic and you might need shielding. Yes, you might. Now, I've been using the undershelf units without a common ground. So what I'm going to do here is just get some of that aluminium foil. If I need to shield it, I just put a layer on each side and I can decide what I want to do with the grounds. The other thing is that a problem I had with this one is because I didn't want common grounds, I had to make sure that I used insulated connectors or sockets over here. These things are not the best. The ones that I prefer are these, but these are not insulated. I can't find the ones that have got the little bushing, the little plastic insulators, and these are the cheapest anyway. So what I can do here is I can still use this plastic, but when I put the shield on here, I leave an opening where the socket's going to connect to, so it doesn't create a common ground if I don't want it that way. So let me show you how I design this. I do this in Fusion 360. You can do it in SketchUp. You can do it in all sorts of CAD programs, 3D modeling programs. Fusion 360 is the one that I've sort of basically learned enough of to not want to move away from it. Once you've learned something, stick to it. And then I'll show you how the slicer program that is actually indicated as the best one for this printer. It's actually Bambu Lab Studio. They've got their own one, and that was incredibly easy to use, especially for this particular printer. Just so that you know, one of the greatest features that I found on this is that you can actually send the files to print via your local network, via Wi-Fi. Now, with the one that I had to actually save it onto an SD card, change the SD card around, put it into the printer and print it that way. With this thing, I just send print from the computer and it does the job. So let me show you the design for this. Well, folks, here's the actual design of that module. I'm not going to go into all the detail on Fusion 360. This is not a tutorial on Fusion 360, but I will show you the steps that I went through to get there. And this is great because you can actually go to the beginning and start stepping forward, and you can actually see what was designed. If I look at the sketch that I did here, I created the the element 65 by 65 millimeters, 10 millimeters there. I gave it a wall of 2 millimeters thickness, and then if you carry on going forward, you see what happens. This thing gets extruded. So I extruded up 10 centimeters. Now this extrusion, here's the beauty of it. If I want to make this bigger or smaller, I can do that. I can make it any height I want. Now, as it is, I've got it at 100 because I designed everything for the previous version. So I left it at 100. But that is now something that I can use and make it as big or as small as I want. And then if I take it one step further, what did I do next? I think I drew I'm going on the timeline down below because you can actually step through. Yeah. I drew the 3 holes on here, and I can show you those as well. That is the 12 millimeter diameter. This is about halfway up across the, actually I should make it exactly halfway. Yeah, I'm probably going to shift this up a bit. This is 30, let's see, what did I make this? 31, so I can make it 65, 32 and a half, 32.5. Make that 32.5, and that will also go to 32.5. So I can just move that. What am I moving? 1.5 minus 1.5. Okay, so that gets done, and then you can extrude it and you get your holes. So I've got the holes in the front the way I want them. Brilliant. Nothing at the back yet. No rounding, no nothing. And then if I take it further, what did I do next? Well, I made the hole for that lead, as you can see, nothing too special. And then I drew that element at the back because I wanted it to come out, and I wanted to do it all in one hole in there so that I can screw it to the underside of the shelf. I rounded the hole at the end there, and I made it a little bit nicer. Yeah, it's all nice and smooth and round. And then I put the holes in the back. Now the holes in the back, what did I use this for? I can't remember anymore. Yes, I put them at the back. This one here is for the power. So 12 volt DC is going to go in here. It's a power socket. I'll be running this on a battery, which I'll show you when I build the project up. This one here is the mini whip coming in, and this one is the FM antenna coming in. Let me just check that this is halfway. I'm not sure if I did it the same as the other one. 32.5, yeah, that's halfway. So this is done. Now, what do I do next? Well, what I do next, I could do all sorts of other stuff. I could round this off. I'm not going to do that. I actually did a version where I built the sides up, but then I realized that working inside with the sides done is actually quite difficult. So I left it open, and I've designed these side panels that slip in here, which I'll show you in a moment. But I can then export this. I'm going to export it, and I'm going to export it in STL. And I'll export it to the desktop. I'll show you what I do with that next. So that's one part of this whole thing. Let me show you the other one. Right, here's the front panel. And the front panel is practically the same as I did before. I do need to make one small change, and that is, I think it's on this one here. Yes, I need to make that 32.5. Otherwise, it will not match up with with the ones I've got at the back, or rather on the main module. So that's all done. And then this one is actually thinner. This is actually 1 millimeter thick. So you can see that. That's a very, very thin layer, done on purpose so that it doesn't actually add much thickness to the whole thing. Then what I did next, let me go back to the timeline. Then I put the logo on and the name of the module, and then of course the other labeling that I want done. Now, the way I did this is I did the writing. I did the writing on here, and then I extruded it. I should actually move this up 1 millimeter. This thing is, what do I need to move it up? 1.5. Because I did the other one at 1.5. So I've now got this as sort of a template, because I can come back at any time and change this. I can actually edit this. You see, I can, if I do a different unit, I can edit this whole thing. Change the text on there, and I'll have a new faceplate. But this one is ready, and I'm going to save it. And I'm going to do the same thing. I'm going to export it to STL. This is the front panel. Export that to STL. Okay, that's gone. Now I've got another one, which is the back panel. And the back panel is practically the same idea. What it is, the same idea. I designed it. I did a cutout there for that little unit that's going backwards to hold that L bracket. And as you can see, this thing is also 1 millimeter thick. This one I can export as well as is. I'm not making any changes. But as you can see, I can very easily edit any of this. You know, I can edit any part of this depending on what I want to print. So effectively, these 3 files are going to be here as templates in a way, so that I can then just adjust it any way I want, depending on what module I'm building. So let me export this one as well. Right, and I have one more thing here, which is this one. This is the side module, the side panel that I've designed, and this thing takes 2, but I print one and then I mirror it and I print the other one, and it fits nicely into the side. There's no mystery here. This is more, well, you've got to look at quite a few tutorials on Fusion 360 to get to this point. Some of you will be faster, some of you will be slower, but it's actually very logical. This whole idea of modeling in 3D is very, very logical. I like it. So let me export that one as well. Right, so we're finished with Fusion 360. Now we've got to slice it. We've got files that are 3D model files, STL files, and now we've got to bring it into the actual program that creates the file that the printer wants to see. Let me show you what that looks like. And here's the software that I use. This is Bambu Studio, so you download it for free. And in that description that I gave you in the beginning, or showed you very briefly, your printer is actually connected to the network, which means that from here I can send prints immediately to the printer and it'll just start doing its thing. But if I want to prepare a project like I want to do now, and I'm going to do the frame first, so I had it on the desktop, I just bring it in here and look what happens. Now, when I set this up, I literally left it like this and I said slice plate. I hadn't put, okay, it's telling me that I haven't got support. Okay, no problem. But I literally did that with just something else I was trying, and I sent to print. I'm not going to do it this way. I'm going to actually go back, and I'm going to show you what happens here. The one thing that I've decided to do is I've decided to print it flat. So I'm going to actually do that. Go back to prepare. And the one thing you need to do here is you need to tell it which filament to use first. Remember, I've got 4 filaments. I've changed now to black. These are the filaments over here. This is using the AMS, automatic, what is it, management system, is it? Something like that. I can choose any of the filaments that I have on there. I've got gold, I've got black, I've got white, I've got red, I've actually just gone down here, changed filaments to black, to white rather. So that's white. Now I'm going to just rotate this, and I'm going to rotate it so that it's flat. There. And I think I can just print it like this now, but see, this thing is an overhang, and that's an overhang. So I'm going to give it, let's see, I'm doing the presets. I'm using the presets as standard. Strength comes out at 15%. I didn't change any of this. The only thing I did is I enabled supports, and I've made it tree. Just because I prefer them. They're easier to remove. And if I slice it now, this is the slicing. This is what's going to print. Okay, the greens are the supports, and you just pop them out at the end. But you see, literally just using a preset, the standard, and just adding supports. And I can now, let's see what time this gives me. It gives me 6 minutes, 20 seconds prepare, printing time 1 hour 47. So this thing takes quite a while to prepare because it actually does bed leveling. It does all the configurations in itself, by itself, before it starts printing. But this thing prints in 1 hour 47 minutes. Now, let us see what happens if I try to do the same thing with the other slicer on the other printer. Now, this is the slicer that I used to use, and it's configured. It's standard 0.2 millimeters as well. And if I do that, let me just push, where is it? I've forgotten how to use this now. Tree, yeah, I've got supports, okay. And I'm going to say slice. Nine hours, 9 minutes. Bloody hell, even I'd forgotten how long this took. 9 hours, 9 minutes, and I've got everything practically the same. 0.2 millimeters. What have I done here? I've put 20%. Let me put 15%. It's going to make very little difference, but 9 hours, 9 minutes. Whereas the one that I've got here says 1 hour, 47 minutes. See what I mean by fast? This is incredible. Now, all I need to do, I just want to check that I've got everything. I'm going to push print. And it's detected my printer on the network. Let's see, what is it doing? Refresh, what am I doing? Bed leveling, I can get it to bed level. I always do this. I just leave it as standard bed leveling, flow dynamic calibration, enable AMS because I'm using one of the filaments. You can do a time-lapse film and all that jazz. I don't need that. I just send it. I don't have to save it to a SD card or anything like that. And I should hear this thing start going funny on my left here as soon as this goes through. And then it starts giving me the progress. There we go. It's jumped to the device setting. And again, another series of videos that I'm going to link below, which were very, very good in teaching how to use this particular software. So I'll be linking that below as well. It's a series of videos, and it is absolutely excellent. Excellent. It's about 6 or 7 videos. There, the printer's starting. It's actually quite amazing. It's got a camera in there that you can see remotely. Not that, yeah, I suppose you can use that too. It's very slow frame rate, but it gives you an idea of the progress. You can see the mess in the background there. That's the box that came in. So I've got to clean this place up. But it's doing its business. It's aligning itself. It's, what is it, homing the tool head. It does all these funny things, and then it starts working, okay? So that's what I'm going to leave for a while because I want to show you the result when this thing finishes printing. I'm not going to show you layer by layer. No, I don't want you to get old. I mean, this thing is fast, but 1 hour, 47 minutes is still a pretty precious part of your life and mine. All right, I'll show you when I've got that done. And here's the result so far. I printed the main section. This thing really does a great job, as I've kept repeating. I'm just so fascinated. And at the end, you're left with all these trees. These were the supports. You can also do the normal supports, which are just vertical. These things come out quite easily. You let the bed cool down. You have to let it cool down a bit. And then it pops off the bed. and you break these away. They break off quite easily. In this particular case, I pulled it off while it was still, probably while it was still hot, so it did pull a little bit of that off, but this is on the underside, so I'm not too worried about it. I'm not going to print it again. And then, of course, I printed the sides, which I didn't even show you because it was just a matter of printing and choosing the black filament. And now I'm going to do the interesting part, which is the faceplate with the multicolor printing. That is always cool to watch. Right, let's do the faceplate. So let's bring one in. I'm going to do the two at the same time because they're both the same colors. Now, first of all, I've got to change the filament color to white. The base filament color is white. All right, let's lie these guys flat. Flat on the bed. Okay. I'll just make that a little bit, put them together. Now, these two are the same thickness. You can see that. And the lettering is the same height. So this lettering here and that lettering here is the same height. And that one is the only one that sticks out a bit more. Okay. So what I'm going to do now is I'm going to start painting it. Now we've got the base as white. Now what you do, choose one. I think you may be able to choose two. I'm not sure. No, you can't. Anyway, you go to painting. Okay. And the way I do it, this is the easiest way that I've learned. You can paint this like anything you want. Okay. I'm just going to undo that. You choose the color of the filament and you use paint. But that's not the way I like to do it. I want to do layers. And remember, I'm still sort of learning this, right? So I choose layer height and I click on there. Yeah, there we go. Now, if I go here, I can, oh, wrong color. Stupid. I want black. I want that to be black. Start again. Choose the color, choose black. That's black, but I want to give it some thickness, so I'm going to paint. Oh, I went too far. I touched the bottom. There, that'll do it. All that lettering on that layer or on that height, remember this thing's printing from the bottom, sort of printing up. All that there is now black, including, as you can see, the bottom part of that. Now I've got to go and change to red, and I do that guy, and I'm going to give that thickness. There we go. That's all it takes. That's literally all it takes. Now, if I return and try this one is easier. I'm just going to choose black there and do the same thing. Give it some layering. That should be it. That really should be it. Now, what I'm going to do here is I'm going to do not the standard. That's 0.2. I'm going to give it 0.16 high quality. Bambu Lab A1. There we go. I don't need supports. And I'm not going to do anything else. I'm not doing anything else. Now, just check this out here. This is cool. It creates a little platform on the end with all the colors that are used in order to basically to start the printing. I think it's to prepare the nozzle and the flow rate, because it actually checks the flow rate, I think, to ensure, is that it? Am I making this up? I think it's to ensure that, this seems to be illogical to me. It's to ensure that the flow rate is good when it goes and does the change of color. I actually thought this should be vertical. Anyway, as you can see, I'm still in the throes of the initial learning phase of this thing. So I'm going to slice the plate, and it should do it in 45 minutes. Okay. And I'm going to, oh, by the way, if you go here, if you want to see what's happening here, this here gives you the layers. And you can go down. You see how it's sort of, actually let's go to the bottom. When it starts at the bottom, it starts with the base layer. Stupid. 3, 4, 5, 6, 7. It starts with the lettering in black, right? 8, layer 8, more lettering in black, more lettering in black, and then when it finally gets to the top, it prints the last 2 layers in red, just on that part over there. Okay, so let's print this thing. And it is using, as it basically knows, it's using 3 colors, black, white, and red. I'm leaving everything the same. I really want to show you that I'm not one of those people that sits and changes speeds and all that jazz. I don't know how to do it. When I find out how to do it, I probably will. But at the moment, I leave everything as standard as I can. I really love this wireless idea. You just send it and it starts the business, and you don't have to worry about, popping out SD cards, and you don't know which way around it is, because the other one I had a very small SD card. There's micro SD cards. So, yeah, okay. Next time you see it, hopefully we'll have some face plates front and back. So here we go, all parts printed. And I had to redo this one because I had actually made a mistake on the spacing at the back, believe it or not. This is the beauty of having a machine where you can do your own prototyping, because you can just redo it. So I redid this one, and the other thing I noticed is that this one is best printed vertically, because when I printed like that, there was a little bit of a sort of indent there, which could have been pulled out, but I preferred to do it like that. It came out pretty much perfectly. And now all I need to do is start applying, well, let me show you the other parts. This is the back end, which will go there. Here's the faceplate, which will go there. And these are the side panels, and they fit like that on this side and like that on that side. I had to leave that little indent so that it can clip onto that rail that I've got under the shelf. And now it's time to put this thing together. And what I'm going to do is I'm going to put the hardware that mounts on the front and the back. So all I need to do now is I can place this over here and start adding the hardware which will hold it in place. And I'll do that and then show you the result. And here's the final result with all the sockets and switches on the front. As you can see, these guys are actually holding that little faceplate in place. There's no need for glue. I mean, if I did this, I can warp it, but this thing is perfectly flat. So with these 3, it holds it perfectly in place. It's easy to access and work on. This is why I left the sides open. The back, same story. I've got my 12-volt DC supply here, which I'm actually going to be supplying from a battery pack. I'm not going to use a transformer this time. I wanted to make the supply to this as clean as possible, so I built this 3-element 18650 with a battery management system. It gives me between 12.6 and 11.1 or something, and then I can charge it normally. I've got a little note here as to how to charge this thing. This thing has the socket here, the jack, and it will plug into here, and it will probably be velcroed to the back of the panel, the top. I will probably be using this idea with a few more elements on my system over here, because some of them really need clean supplies, and preferably not ground referenced. This is not ground referenced because this is obviously not conductive, but I may buy or use a sheet of aluminium foil, the self-adhesive stuff. Put one there, one there, one there, make sure they're touching, and make sure they're not touching those elements, because I don't want them shorter to ground, and because it will pick up noise in this particular case. But that's it. I am extremely pleased with this result. This thing has worked perfectly, and I know myself quite well. I will be making changes. I think I'm going to get rid of that ridge, or that bezel, whatever they call it there, and make this thing fit snugly. Maybe not. Maybe I will. I know I'll probably change something. I may actually make this embedded, sunk in rather than coming out. Again, I'm going to play with this thing. The point is that it's very easy to produce and to change. And this is the beauty of having a machine at home that you can do your own prototyping on, because prototyping never ends. This is my problem. I never stop changing stuff, trying new things, see what it looks like, see if it's better than the last. You know, that's what you do. That's what you do. So this is it. This is the result of my new Bambu Labs A1 Combo printer, the one with a combo version on it with the multicolored filaments. And I am going to make one little adaptation to it. And that is, I'm probably going to take that unit with the 4 reels or spools of filament and find a way to put it against the wall at the back, because it does take a lot of space. And there actually are quite a few designs on the net where they show you how to maybe put it on top. I don't want to do that. It's a bit too heavy for that. There's one where you can put it against the wall or at the back. And that's probably what I'm going to do, because it does take quite a bit of space. And I do want the 4 elements. This thing actually comes with the possibility of using only 1 spool. So you don't have to use 4 and you don't have to have all the space. The single spool one has an adapter for the top, the feeder. But once you try this, it's difficult to give up on it. And I will be making some adjustments. The beauty of this, the whole 3D printing thing, is that it's like restoration of tube radios. It's a community and people produce stuff and share it and all that. The other thing I'm going to have to do soon is order another black and another white reel, because the white is going through quite fast. I've done a lot of printing, a lot of testing. As you can see, this is all junk now, but you know, that's what I do when I'm trying to learn something. So I will be needing some white soon, and I do want to use theirs. Theirs comes with an RFID tag on the actual spool so that the printer itself knows what color's there. This is fantastic. You don't have to have that kind of spool, but the ones they have identify themselves, which makes life a lot easier. So that's been my little saga with the 3D printer. I want to thank Bambu Labs for the printer. I'm so happy that I can say good things about it. If I didn't have good things to say about it, I probably wouldn't say anything. I'm going to use it all the time, and I can say good things about it in good conscience. Is fantastic. Right, that's where I'm going to leave you for now. And I hope you've enjoyed this. And if you have any questions, post them in the comments. And if you've enjoyed the video, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Once again, thanks for watching. Bye for now. And most of all, stay safe.